Hey all, so in this video I'll be going over the 2024 NHT Exam 2 for Maths Methods, and I'll be going over the section 2. So without further ado, let us get started. So question number 1, f of x is equals to this, where p is r. Part of the graph of f is shown below when p equals to 3. Find the values of the x-intercepts of f when p is equals to 3. Okay, so let us do this question on calculator. So let's define f of x equals to x cubed minus, what was it, px, p times x, and we have to find the x-intercepts when p is 3. So solve f of x equals to 0, comma x, and we know that p is equals to 3. Okay, so these are our x-intercepts, so let's write them down. So we have x is equals to minus root 3, x is equals to 0, and x is equals to root 3. Okay? Now, use the derivative of f to find the coordinates of the turning point of f when p is equals to 3. Okay, so in that case, let us differentiate the function using calculator and go from there. So let us define df of x equals to menu for 1. Okay? And we'll find the stationary point, so df of x equals to 0, comma x, and make sure that p is equals to 3, okay? So x equals to minus 1 or x equals to 1, we just substitute that back in, so f of minus 1, I have to write when p equals to 3, okay, and f of 1. Okay, there we go, and what is our derivative function? So okay, cool. Alright, the reason why I found the derivative function is that this question is 2 marks, so I'm assuming that they want me to also give them the actual derivative. So we can write this, so f dash of x is equals to 3x squared minus 3, and f dash of x then set equals to 0 to find the stationary point. So we found x to be negative 1 and x to be equals to 1. And then what we did, we substituted that back into the function. So f of negative 1 was equals to 2, and f of 1 was equals to minus 2, right? So our stationary points are negative 1 and 2, comma 1 and 2. Okay? 1 and negative 2, I mean. Okay, hopefully this made sense. Let's go to the next question. So find the value of p for which f would have exactly one stationary point. Okay, let's go back to the cast for this. So df of x, so we can see that this in terms of p, right? And this is a quadratic expression. And what the question is asking is that we need only one stationary point. That means the question is indirectly asking us that we need to find p such that this quadratic expression only has one solution. So we can use discriminant for this, right? Because we know if we want only one solution, we set discriminant equals to 0. And discriminant has a formula that b squared minus 4ac. Okay, so let's solve for that. So solve, what is our b? Well, we don't have a b here because this is a and this term is going to be c. There is no b term. So b is just going to be 0. So the only thing that's left is minus 4 times a, which is 3 times c minus p. That has to be equal to 0. So p has to be equal to 0. So answer for this is going to be p equals to 0. Okay? So find the values of p for which f would not have any stationary point. So for it to not have any stationary point, we know that discriminant has to be less than 0, right? So nothing changes except we put a less than sign, and there you go, that's your answer. So our p has to be less than 0 if we want to have no solutions. Okay? Alright, so the graph of f passes through the origin for all values of p. That's correct. Use calculus to show that the tangent line of f at the origin has an equation this. Okay. So in this case, now we have to show some working out, of course, because it's a show that question. So what we'll do is, we'll first show that the gradient at the origin is going to be negative p. So we'll write f dash of 0 is going to be equals to minus p. I mean, looking at the gradient, that is. So let's have a look already on the cast. So df of 0, there you go, so minus p. Okay, so currently our equation looks like y equals to minus px plus c. Now we know that it is passing through origin, right? So that means the other coordinates we can take is 0 and 0. So we'll have 0 equals to minus p times by 0 plus c. So therefore, c is equals to 0. Okay? And hence, y equals to minus p is the tangent at origin. At the origin. Okay? So find in terms of p the area of the region bounded by the function f, the line y equals to minus px, and the line x equals to p, where p is greater than 0. Okay, so for this, let's plot this function on CAS to have a better visual of what's happening. So f of x, we'll have to add the slider, of course, and then we'll plot the other function, so minus p times x, so that's our linear line. And we have to also plot one more thing, if the calculator lets me, so graph, and we'll do relation x equals to p. Okay, now let's zoom in, so menu 4, and we'll do zoom box. Alright, so we are basically finding the area bounded by the function f, so this, the line, and x equals to p. So we are looking for this area over here, right? Now, as you can see, regardless of what I actually make the value of p as, the f of x is always going to be larger than the linear line, right? So our integral would be from menu 3, and then we'll have 0 all the way to p. Okay, well, p is defined. So how do I undefine the value of p? So we press menu 1, 3, p. So this is the deleting the variable p. Okay, now we can find the area. So we have menu 4, 3, 0 all the way to p. And we did see that regardless of what we put as a value of p, the f of x will always be larger than the linear line. So we'll have f of x take away minus p times x. So that just ultimately becomes plus p and dx. So that is going to be our area that is required. Okay, so let's write that down. So as you can see, this is a 2-marker question. So what I'm going to do to be safe is I'm also going to write the integral. So we can say that from 0 to p, f of x plus px dx is equals to p to the power of 4 on 4. Okay, so we have given the answer, and we have also shown some working out. So hopefully that is enough for the 2 marks. Okay, the expression for the area found in part dii, which is this part over here, also gives the area bounded by the cubic function y equals to kx cubed, the x-axis, and the line x equals to p, where p is greater than 0. So find all the possible values of k. Cool, so in that case, what I'm going to do, I'm going to quickly plot y equals to kx cubed as well. Okay, maybe I'll delete this one and I'll open a new one. So k times x cubed. And of course, we have to create the slider. And we also have to plot x equals to p. So we'll do 6 x equals to p. Okay, now let me move this up. Cool. Now as you can see, so p equals to 1. Now p has to be greater than 0, right? So let's leave it at that. What about k? If I change the value of k, right, okay. So as you can see, if you look at the area, so if I do menu 4 to zoom box, let's do something like this, okay? Alright, so if I do k equals to 2, we are looking at this area, by the way. So we are looking at the area bounded by this graph and the line and the axis. Okay, so we're looking at this area over here. So now if I were to move this area, as you can see, this area and what we saw was symmetric, right? So it's basically the symmetry that they want us to realize. Okay, and we want this area to be the same as p to the power of 4 on 4. And what values of k would achieve that? Okay, now there's 2 things I want to cover. Okay, so if I come back to the iPad real quick, let's draw this. So, okay, draw a straight line. Okay, so if I were to draw this graph, okay, and let's say that this is my y equals to p, right? So let's say when k equals to 1, this is going to be it, right? So as you can see, we are looking at this area over here. Okay, now what happens if I flip the graph? So let's say I'm drawing a graph for k equals to -1 now. So we'll go from here all the way to here. Now of course the areas like this area and this area doesn't look the same, but it's basically just reflected as we saw on the calculator, right? So what that means is that if, for example, k equals to 1 or k equals to whatever value we get for the same area, we have to include the negative of that value as well. Or in simpler words, what we are basically asked to do, like this is a graphical visualization, but if I were to show you in mathematical notation, what we are basically asked to find is the fact that we integrate from 0 to p kx cubed dx, right? And then we take the modulus of whatever we get here. Why do we take the modulus? Well, because we are looking for the magnitude, like the same magnitude. We are not looking for the sine area, we are looking for the total area. So what I mean by that is this over here is the total area under the graph. And we want the total area, not the sine area. What's the difference between the sine area? Well, say for example, we are looking at this, let me erase this. So let's say for example, we have a function that goes like this, right? So this area over here, in terms of sine area, this area would be considered positive, this would be considered negative, and this area would again be considered positive. Whereas in total area, regardless of what the signs are, we just simply add all the areas up without taking into account if it's a negative area or a positive area, right? So that's why we do add the magnitude sign. So magnitude sign basically makes the whole area total area, and we want the total area to be p to the power of 4 on 4. Okay, so if I were to do this on CAS, I think that would make more sense if I were to do this on CAS. So let me undefine the variables p and k. So menu 1, 3, p and k. Oh, I can't do 2 at the same time. Okay, p and then I'll do k. Okay, now we'll set the integral of, so menu 4, 3 from 0 all the way to k, p, I mean, k times x cubed dx. Okay, so we get this area over here. Okay, now if I were to just solve, that is equals to p to the power of 4 on 4, comma k. Yeah, we get the answer of 1. It's not wrong, but we are looking for the magnitude, okay? This is the magnitude of the area. This is the total area, okay? So what we have to do is we have to do something similar, except here we have to go back here and we have to put the magnitude sign. And that is equals to p on 4, p to the power of 4 on 4, basically. Okay. And these are the values that we need for k. So k equals to -1 or k equals to 1, both will give us an area of p to the power of 4 on 4. Okay, so that's the understanding of this. So let us write that down real quick. So k equals to -1 and k equals to 1. Okay, hopefully this made sense to you guys. Okay, so question number 2. A simple pendulum consists of a mass at the end of the string fixed at length 0.5 meter. The other end of the string is attached to fixed point O. Okay, the mass swings back and forth in a circular arc between the points A and C, each time passing through point B. The height h meters of the mass above the horizontal ground is given by the function this, where theta is the angle in radians measured anti-clockwise from vertical line OB. So measured like this basically. The mass reaches its maximum height at point A when theta equals to pi on 3 and point C when theta equals to negative pi on 3. It reaches minimum height at point B when theta is 0. Okay, pretty obvious. Even if you look at the visual, we can easily tell that the mass will be at its maximum over here and over the maximum, like at its maximum height. Okay, this is the maximum height, and here, as you can see, this is the minimum height. Pretty obvious looking at the picture, so that makes sense. Okay, and what we have to do is to find the maximum and minimum heights of the mass in meters above the ground. Okay, very well. So they have basically given us the answer because, well, we have the equation. We know from the question itself that maximum will occur here, and minimum will occur here. So we already know everything. So let's just do this on CAS now. So let me insert a new problem. Okay, and define h of x equals to, what is the function? So 3 on 2 take away 1 on 2 times cosine of x. So let's find the maximum. So maximum will occur at pi on 3. There you go. So 5 on 4, and minimum will occur at h of 0, 1. Okay, so that's that. So maximum is equals to 5 on 4, and minimum equals to 1 meter. Okay, so yeah, find, correct to 2 decimal places, the values of theta for which the mass has a height h less than 1.1 meter. Okay, so what we are basically finding is h of theta is less than 1.1. So let's come back to the calculator, and if I were to plot the graph of h of x with the domain that it's from negative pi on 3, let me copy that, less than x less than or equals to pi on 3. And if I want to get a better view, we press menu for A. There you go. So this is giving us a better view of the graph. And if I were to plot 1.1, so we are basically finding all the values below here. So this is when h is equals to 1.1, and we want the values of theta for which it is less than 1.1. So we are looking for all of these values over here. So what we are going to do is we'll find the intersection. So h of x equals to 1.1 comma x, and of course we have to specify the domain that x is between negative pi on 3 less than or equals to pi on 3. Right, so these are our intercept. So if I were to go back here, so this is the intersection, which is negative 0.64, and this is the positive 0.64, right? And anything between that value we can see has a height of, results in a height of less than 1.1. So that's all we are looking for. So let's write that down. So theta is between, what was the value? Let me check. Yeah, so it's negative 0. How many decimal places? 2 decimal places. 0.64 to positive 0.64. Now of course we cannot include this. The reason being that if we include this, again we'll get it wrong because we are simply asked for less than, okay? Not less than or equals to. So be careful and make sure you get your reading done correctly, so you avoid making the silly mistakes. Okay, hopefully this made sense. So 2 marks. I guess 1 mark is for showing that you understand what we are finding, and the other one is just for the answer. Alright, so let's move on to the next question. So the angle theta radians as a function of time is given by the function this. Show that the mass is initially at point A. Very well, so before we had this theta over here, right? And now what they've done is they have given us they have made the theta also as a function of time. So now the angle basically depends on the time that has elapsed. Okay? Show that the mass is initially at point A. So let us define the theta function first. So I'm going to define it as f of x. Define f of x equals to pi on 3 times cosine of 9 times x on 2. Okay, and show that the mass is initially at point A. Well, so let's see what results, what will happen if I put t equals to 0. Well, you can see that t equals to 0, we get pi on 3, and that is exactly when it's at A, because if you look back over here, when theta is pi on 3, it's at point A. So we just had to prove that it's at the starting point happens at pi on 3. And because it's a show that question, let's quickly write some steps down. So we'll say theta of 0 is equals to pi on 3 cosine of 0. And that results in pi on 3. Okay? And point A is when theta equals to pi on 3. Therefore, mass is initially at point A. Okay, done. Determine the period of the pendulum. The period is the time in seconds taken for the mass to travel from A to C and back to A. Okay, so in that case, we are just determining the period of this function over here, right? So let's do that. So what is the formula to calculate the period of cosine function? It's just 2 pi on n. So let's do this on calculator. So 2 pi divided by 9 divided by 2, and then we'll get 4 pi on 9. So our answer will be 4 pi on 9 seconds. Okay? How many times for t belongs to 0 and 30 is the mass at point A? Okay, so let me draw a quick visual. So let's say this is our starting point and this is my string, and this is at point A at the moment, right? So that's one period and it's back at point A. That's second period and it's back at point A. That's third period and it's back at point A. So all the question is asking us to do is to find the number of periods that occur between 0 and 30. Now how do we find that? Well, that's pretty simple. We can simply divide 30 by 4 pi on 9, right? Because that will give us the number of periods of this graph over here that happens between 0 and 30. Does that make sense to you? Okay? So that's the idea behind this. Okay, so let's divide this. So 30 divided by 4 pi on 9. So there are the periods. So basically this many amount of periods happen between 0 and 30. So basically this will be our answer. Okay, so we can say that our answer is going to be 21 times. Okay, wait, actually no, it won't be the answer. This is a bit of a tricky question because the mass is initially at point A. So that means that does count because at t equals to 0, so we are including the position at t equals to 0 as well. And at t equals to 0, it is at point A. So we have to add plus 1 to this, okay? So the answer will be 22 times, okay? This is a bit of a tricky question, but hopefully this made sense to you guys, okay? So determine the distance in meters that the mass travels as it swings from point A to point C. Okay, so if we go back to the picture, we are basically finding this distance over here. Well, you get the point. Okay, now distance on a circle, well, that's similar to circumference, right? We know how to calculate the circumference. It's 2 pi r. So this is our whole circle, and if I want to calculate the circumference of this whole circle, it's 2 pi r. But what if I want to calculate the circumference of just this part where theta is given? How do I do that? Let's say this is theta and I want to calculate the circumference of this part over here. How do I do that? Well, we can say that the formula for that is theta on 360, or you can say 2 pi if it's in radians, times the 2 pi r, right? So this and this would cancel out, so we'll have pi r, theta r, to calculate the circumference of the specified portion. Okay, so let's use that formula actually, because we know that this over here is pi on 3. We know this over here is also pi on 3. So the total, the whole thing over here is going to be 2 pi on 3, right? So 2 pi on 3 times by the radius. What is the radius? 0.5. So 1 on 2. That cancels out, leaving us with pi on 3. So pi on 3 will be our answer for this, okay? Hopefully this made sense. So let's write that down. So it will be 2 pi on 3 divided by 2 pi times 2 pi r times the radius, which is 1 on 2. This and this would cancel out, this and this would cancel out, leaving us with pi on 3 meters. Okay, hopefully this made sense to you guys. Alright, let's move on to the next question. So find, correct to 2 decimal places, the height of the mass in meters after 1 second has elapsed. Okay, so we have to find the height after 1 second being elapsed. Okay, so how do we do that? Well, we are given a function that is in terms of time. So theta function with respect to time. And what we have to find height. So basically, we are given h of theta, and then we are given theta of t. So what we are basically finding is that first we have to find the theta at t equals to 1. So once we have that theta, we have to input that value of theta in here to find the actual height, right? Or in other words, what we are basically finding is h of theta of 1, right? Does that make sense to you guys? Okay, so I'll erase everything here, and that is equals to, let us find this on CAS, so h of f of 1, that is equals to 1.01213. Okay, so 2 decimal places, that will be 1.01. Okay, hopefully this made sense to you. And meters, because we are finding the height of the mass, so meters. State the rule for the composite function h of theta of t. Well, this is just copying down, so h of f of t. There you go. So let's copy that function down. So h of theta of t is equals to 3 on 2, take away 1 on 2 cosine of pi on 3 cosine of 9t on 2. Done. Okay? So find correct to 2 decimal places the average height of the mass in meters. Okay. So, okay, in that case, so we are given the 2 bounds, which is 0 to 30. Okay? And we know that to find the average value, we have the formula that average value is equals to 1 on b minus a integral from a to b f of x dx. So in this case, we can use the same formula. Okay, so we'll have 1 on 30 minus 0, so that will just become 30. So 1 on 30 integral from 0 to 30 of h of theta of t dt. Okay, so let us do that. So we got 1 on 30, and you for 3 from 0 all the way to 30, h of f of x dx. So average height is going to be 1.13 meters. Okay, hopefully this made sense. Next page. Oh, blank. Okay. Alright, here we go. So question 3. A small business has 4 people working full-time. The business rents an office, and on most days some people work from home. Fair enough. On any given workday, the number of people working in the office can be modeled by the discrete random variable n with the following probability distribution. Find En, the expected value for the number of people working in the office. Okay, so we just expected to find the mean value. So that will just be 1 times 0.3, so that is going to be 0.3. 2 times 0.4, so that is going to be 0.8, plus 3 times 0.2, so 0.6, plus 4 times 0.1, so that is 0.4. Okay, so let us total this up on calculator. So we have actually let me insert a new problem. It's better to keep things separate. So yeah, 0.3 plus 0.8 plus 0.6 plus 0.4. Okay, so that is 21 on 10 days. Or we can say 2.1 days. Okay? Find the probability that all 4 people are working in the office given that at least 2 people are working in the office. Okay, so probability that 4 people are working in the office, so n is equals to 4 given that at least 2 people are working in the office. So this is a conditional probability question. Let's recall the formula. So probability that A given B is equals to probability of A intersection B divided by probability of B, right? So in this case, we have to find the intersection of these two. So let's draw a number line real quickly. So this is our n is greater than 2, greater than or equals to 2. And this is our n is equals to 4. So where is the intersection exactly? That's right. The intersection will occur at n equals to 4 only. That's it. So we can basically write that this is equals to probability that n is equals to 4 over probability that n is greater than or equals to 2. We are given the probability that n equals to 4 is 0.1 divided by probability that n is greater than or equals to 2 is all of these three added together. So that would be 0.4 plus 0.2, which is 0.6, plus 0.1, which is 0.7. So 0.7. And that is equals to 1 on 7. Okay? So that's how we do this question. In a fortnight with 10 work days, find the probability that all 4 people are working in the office on at least 3 days. Okay, well, so we are using a binomial distribution for this question, right? So what we have to first do is to define our random variable. For these sort of questions, it's important that you define the random variable. I know that people can just say that x is, binomial from 10 and then 0.1. But sometimes what happens is there are a lot of variables in the question, and what is x? Sometimes the marker can get confused. So it's better to explicitly state the following statement. So I'll say that let x be a random binomial variable to denote the number of days that all 4 people are working in the office. So now you have made it clear what the x represents. So now if we use x, there shouldn't be any problem, okay? So we are basically finding, now you can say that we are finding probability that x is greater than or equals to 3, and that will be fine, okay? And now we can also write that x is binomial. What is our number of trials? So the syntax for this is going to be x binomial and n comma p, where n is the number of trials. So we have 10 working days, so that is going to be our number of trials. And what is the probability that all 4 people are working? 0.1. So our probability is 0.1. So now we are finding probability that x is greater than or equals to 3 because we are finding the probability that all 4 people are working in the office on at least 3 days, right? So let's do this question on CAS now. So menu 5B, number of trials 10, probability of success 0.1, lower bound is 3, upper bound is 10. Bam. So this is going to be our answer. So our answer is 0.0701. Oh, actually 0.072. Yeah. So 4 decimal places, so 0.0702. Alright guys, hopefully this made sense to you. The business owner is trying to find ways to reduce costs. Her daily electricity costs in dollar can be modeled by a continuous random variable C, which has a probability density function given. Yep. Identify the maximum daily cost in dollars for this small business. Right. So if C is the one that represents the cost, the maximum cost daily is just going to be 10, right? Because C is a cost, so the maximum cost is going to be 10. So maximum daily cost is going to be 10. Find the mean daily electricity cost in dollars. So that if I were to write the integral, it would be c times f of c dc from 0 to 10. Okay, and let's solve this on CAS then. So let me define the function. So define f of c is equals to, it's a hybrid function, so we'll have to define like this. Okay, so 3 times c times c minus 10 squared divided by 2500, and it's from 0 less than or equals to c less than or equals to 10, and this one is just going to be 0 elsewhere. Just checking if I've defined it correctly. Yes, I have. Press enter, and there you go. And now we just have to find the mean. So menu for 3, 0 to 10, c times f of c dc. There, so 4 is the mean. So $4. Okay. Find the probability that on a given day the electricity cost is within 2 standard deviations of the mean. Well, what we are finding is probability that mean minus 2 standard deviation is less than c less than mean plus 2 standard deviation. Now, we don't know the value of standard deviation, right? But we do know that standard deviation is a square root of variance. And we also know that variance can be found using e of c squared, take away the mean, whole squared, right? So let us do this on CAS now. Let's find the variance on calculator. So we'll have menu for 3 from 0 all the way to 10, c squared times f of c, keep writing x, f of c dc, so 20. And 20 minus 16 because mean squared, and you know this is our mean. So 20 minus 16, so let's write that down. So 20 minus 16, which is going to be 4. So our standard deviation is going to be square root of variance, which is equals to square root of 4, which is equals to $2. Okay, and what we are finding is probability that mean is between 2 standard deviations. Probability that the cost is between 2 standard deviations. So less than c, less than mean plus 2 standard deviations. So we'll have probability that mean, which is 4, right? Yep. Take away 2 times the standard deviation, which is 4, less than c less than 4 plus 4. So probability that 0 less than c less than a. This is what we are finding. And which distribution do we use here? Do we use normal or do we use binomial? The correct answer is none. We don't use any distributions here because this is a probability density function. The area under the graph represents probability. So all we have to simply do is to integrate from 0 to 8 f of c dc, and that will give us our probability. Okay, so let's do that. So menu for 3, 0 to 8 f of c, I'll just do x, doesn't really matter. So this is our probability. So 0.9728. How many decimal places? Oh, it is not specifying that, so probably exact answer is better here. I think 608 on 625. Okay, hopefully all of this made sense to you guys. Let's move to the next question. The business owner plans to reduce the electricity cost by installing LED sensors. She researches an LED sensor manufacturer and finds the following information. In a random sample of 200 LED sensors, 30 LED sensors were found to be defective. State the sample proportion of LED sensors that were found to be defective. Well, that would just be 30 on 200, which is 3 on 20. Done. Use this sample proportion to find the 90% confidence interval for the population proportion of defective LED sensors. Collect to 3 decimal places. So let's do this question on CAS. So menu 665. We have 30 successes. Number of trials was 200. And we're not finding 95% confidence interval. We are finding 0.90. So 90%. Enter and enter. So our confidence interval is right here. So this value and this value. So this one is lower, this one is upper. Okay, so it will be 0. How many decimal? 3 decimal places. So 0.108 to 0.192. A new sample size is taken, which is used to calculate a 95% confidence interval for the population proportion of a defective LED sensors. This confidence interval, correct to 3 decimal places, is this. Using the value z is equals to 1.96, determine the sample size. Okay, so since the entire sample size has changed, that means sample proportion will also change, right? So we can't just use the 3 over 20. We have to find a new sample proportion. But how do I find that? There's not much information given. Well, there is. So this is how we find it. So because the confidence interval is given, just remember guys that sample proportion is in between the confidence interval. So it is 0.062 plus 0.213 divided by 2. It is right in the center of the two confidence interval. Okay, so let us calculate that. So 0.062 plus 0.213 divided by 2, so 0.1375. So 0.1375. Okay, does that make sense? So this is your new sample proportion, and now we just have to use that to find the value of confidence interval. So what is the formula of confidence interval? Let me quickly check that. Where is the... Okay, so it's just that. So it's the sample proportion, take away that. Okay, cool. I think I can memorize this. And okay, so p hat take away z times p hat 1 minus p hat divided by n. So we know that the value of p hat is, let me just write that down, so 0.1375 take away 1.96 times p hat, which is 1.375, times 1 minus 0.1375 divided by n, and that is equals to 0.062. Okay, so if you put plus here, that is the upper limit, so then your answer would become 0.213. I'm just going to go with the lower one. I always take the lower one, so I'm just going to stick with that. Alright, so let us find this value on CAS now. So solve the mean, so that take away 1.96 times the square root, and then that divided by 0.1375 times 1 minus 0.1375 divided by n, that is equals to 0.062 comma n. Okay, and so 79.9. Okay, so our n is equals to 79.9, but we can take n is equals to 80 because that will still fall under the confidence interval, so that is fine. Okay, hopefully this made sense to you. Let's see. Oh, question 4. Okay, fantastic. So Timothy has created a tiling pattern using transformations of the cubic function this. Okay, on the graph below, the function f is shown in bold. Okay, the rest of the Timothy's tiling pattern is shown with the dashed lines, which are all images of transformations of f. Okay, the translation of f is given by f2x equals to this, describes a different edge of one of the tiles. Trace over the edge described by f2 on the graph in figure 1 and label this edge f2. Okay, so what I'm going to do, I'm going to trace f first and let's follow the transformations after that. So let's see. F of x minus 4. So this minus 4 is basically saying move 4 to the right. Now if it was plus 4, then it would say move 4 to the left. Okay, so move 4 to the right. Let's do that. So that's done. Now what else does it say? It says move 4 down. So This is saying down, move down, and if this was it, then it says move up. So since we are moving down, we move down like this. Done. So this is our F2. Okay? Given that F has a stationary point of inflection at -2 and 2 and an axial intercept at 0, 4, find the values of A, B, and C. Okay, so I think we have to do this on calculator. I mean, we are given like point of inflection. So this gives us 3 bits of information that F of -2 is 2, F of 0 is 4 because there is an intercept, and F double derivative of -2 equals to 0 because there is a stationary point of inflection there. Okay, so we can use these 3 informations to find all of the 3 variables A, B, and C. So let us quickly find that. So first, let me insert a new document. So define f of x equals to, what was the function? Let me go back up. So a times x minus b, why is it all caps? A times x minus b to the power of 3 plus c. Okay, let's define the derivative as well. So menu for 1, actually let me define. So define df of x equals to xf of x. Okay, and let's define the double derivative as well. F of x equals to menu for 1 x and df of x. Okay, and now we'll just use the 3 pieces of information that we got from the question to find the values of a, b, and c. So we'll do solve, and we'll have to do the simultaneous equation. So this one. Okay, and we know that f of -2 is 2. df of, well, we don't need df, so f of 0 is going to be 4, and ff of -2 is equals to 0. So comma a, comma b, comma c. Okay, so these are our values of a. So a is equals to 1 on 4, and b is equals to -2, and c is equals to 2. Okay, so that is the values of a, b, and c. The piecewise function f is continuous, where the first component is f, the other component is translation of f, and both are edges in Timothy's tiling pattern. Complete a possible rule and the domain for the second piece of piecewise function p. Okay, so for it to be edges, I guess it's going to be this function or this function. So either of them should work. Okay, so we are basically asked to find the other piecewise function. So there are 2 answers to this, 2 correct answers to this. You choose which one you like. So you can either choose this option over here, or you can also choose this option over here. Doesn't really matter. Okay, I'll write both of them down. So let's start with this over here, right? So if I want to go from f to here, how would I do that? Well, I have to move 4 units to the right, and then I have to move 4 units up. Does that make sense? Okay, so let me move the f2 back down. So we are basically finding f of x minus 4, and then we moved up by 4, so plus 4 is what we are finding. So let's do this on CAS. First I have to define f of x with all of the values in place. So let's define f of x equals to that. Okay, now we apply the transformation, so f of x minus 4 plus 4. Okay, so this is the function that we have. So let us write that down. So x cubed on 4 minus 3x squared on 2 plus 3x plus 4. And then the domain. What is the domain for this? If we look here again, what is the domain? So the domain is from 0 to 4. Okay, hopefully that made sense. So we will be going from 0 less than x less than or equals to 4. Now of course, please do not include 0 because it's already included in this piecewise function, so do not include it here. Okay, or else that will be mathematically incorrect. So this is one solution that you can write. The other solution here will be this over here. So let's do that as well. So if I were to move from f of x all the way to here, what are the transformations I need? Well, first I have to move 4 units to the left, like so. and then I have to move 4 units down. Okay, so our transformations would be f of x plus 4, because that is 4 units to the left, and then down 4, so take away 4. So let us find that. So f of x plus 4, take away 4. So this can also be our answer, so let us copy that down. So x cubed on 4 plus 9x squared on 2 plus 27x plus 52. And what is the domain for this? Well, the domain is going to be from -8 all the way to 4, right? Because we are looking at this part of the graph only. So that is going from -8 all the way to -4. Okay? So let us write that down. So our domain for this will be -8 including x less than 4, -4. And please do not include -4 because it's already included in here, so we do not need to include it again, or else that will be wrong. So either of this, so you can either write this one over here or this one over here with correct domain and correct rule. You will still be awarded full marks. Okay? So find the rule and the domain of f inverse, the inverse function of f. Okay. So let us do this question on calculator. So we have solve f of x or f of y equals to x comma y. Okay, it doesn't quite solve it for us. That's probably because it expanded it out. So that's okay. It shouldn't take us long to do it either. So we can just say f of x is equals to, what is our value of a? It's 1 on 4 times x. Is it minus b or plus b? X minus b, so x plus 2 cubed. And then c equals to 2, so plus c, so plus 2. Okay? And now we can say swap x and y for inverse. So then we'll have, I'll actually just say y equals 2. So then we'll have x equals to 1 on 4, y plus 2 cubed plus 2. So we'll have x minus 2 and then times by 4 is equals to y plus 2 whole cubed. So y plus 2 is equals to cube root of the whole thing. Maybe I'll just do that. So then our y is going to be cube root of that, so 4 minus x, okay, minus 2. So we can't say y, we have to say f inverse. So f inverse of x. Okay? And we also have to say the domain. So we know that the range of f is the domain of f inverse. So we can write that down. So range of f equals to domain of f inverse. Right? So let us find the range of f. What is the range of f over here? It is going from 0 all the way to 4 inclusive. So our domain for f inverse will be the same. And we can say that the domain is equals to 0 all the way to 4 inclusive. That's the same as the range of f. Okay? Hopefully this made sense. Let's go to the next page. Okay, so let m n is all real numbers, could be all real numbers, and g of x is equals to m times f inverse of n times x be a function describing a transformations of f inverse. Find the values of m and n given that gx described the tile edge joining -4 and 0, -4 shown in bold figure in figure 2. So this is our g of x over here. Okay. Okay, so in that case, maybe I should start by defining the inverse on our calculator. 4 times x minus 2. The whole thing has to be to the power of 1 on 3. And take away 2. Okay. So let's plot this on the graph. F of x from -4 to 0. And then we will plot f1 of x. That is, let's just plot this. So we'll say it goes from 0 to 4, okay? 0 less than or equals to x less than or equals to 4. Okay, let me draw this inverse on our actual grid for figure 2. So it will look something like that. Okay, so this is our f inverse of x. Well, if you look closely, if I were to flip this graph across the y-axis, we will land exactly on g. So all we have to do is a reflection in the y-axis. So let's go back to the calculator and let's see. So f of minus x. Well, f1 of minus x, let's say. There you go. So if I were to restrict the domain from -4 to 0, actually -4. There you go. So as you can see, that we get the graph of g, right? So what is the values of m and n? So if I was to come back to the question, all we really did was 1 times f inverse of -1 times x, right? All we really did was just reflect on the y-axis. That's all we did. So just looking by that, we can say that our m is equals to 1 and n is equals to -1. Okay? Hopefully this made sense. So that's that. Alright. Find the area of one of the tiles. An example is shaded in figure 2. Okay, so let me erase all of this out. So we have to find the area. Well, we are given that f of x, okay? We are given that, and we can see that this area over here under f of x is the same as this area, and this area. Due to symmetry, right? It's all the same. So in reality, all we have to do to find the area of one tile is 4 times the integral from -4 to 0 f of x dx. Now you can find the area above the graph of g as well and times it by 4. It will still give you the same result. Doesn't really matter. Okay. So let us do that on our calculator. So we have 4, 3, and 4 times -4, -4 all the way to 0 f of x dx. So 32. So 32 unit squared. Okay. Using the derivative of f and g at x equals to 4, show that the angle at the left corner of the shaded tile at point -4 and 0 is 90 degrees. So if I were to draw a tangent to f at x equals to -4, we'll have something like this. That is for f of x. And if I were to draw a tangent to g at x equals to -4, that will look something like this. And we are asked to show that the angle between these two is going to be 90 degrees. So what do we know about 90 degrees? We do know that there is a formula, m1 times m2 equals to -1. If two lines are perpendicular, if we, the product of the gradient of those two lines will equate to -1. Okay? So all we have to really do is to find the gradient and see, and then multiply them to see if it equals to -1. If it does, then yes, we approved it. Okay? So let us find the derivative. So we have, do menu for what? Actually, there is an easier way to do this. We don't have to differentiate f of x. We can just simply find a tangent line and get the gradient from there. So menu for 9, f of x, comma x is equals to -4. So there you go. So the gradient is going to be just 3 for that. If I do the same for g of x, oh, there is no g of x. Oh, I haven't defined it. That's correct. So if I do define g of x is equals to f1 of x, that is a strange looking gradient. I don't think that is correct. Oh wait, f1 of minus x. What am I doing? Because g of x has to be is a reflected across the y-axis. So that. And now if I do this, I think this looks a lot better. I think. Okay. So now, yeah, this is 3 and this is negative 1 on 3. So that makes sense. So if I were to say that f dash of negative 4 is equals to 3 and g dash of negative 4 is equals to negative 1 on 3. So 3 times negative 1 on 3 equals to negative 1. Therefore, the left corner, the corner is at 90 degrees. Done. Okay? So, the family of functions defined by y equals to gx minus 8k gives an infinite set of edges in Timothy's tiling pattern, 3 of which are shown below in bold on figure 3. Okay? 3 more family functions can be used to bound an infinite set of tiles centered on the x-axis, so centered just on the x-axis, 3 of which are shaded in on figure 3. Okay? Complete the table to define 3 such family functions in terms of the given functions f or g and find parameter k belongs to z. Okay, so they have given us, what they have given us basically is, this is our g of x, right, if you remember, and they have given us this. So what this means is basically if I were to move this function 8 units to the right, we still land on this. If I move this function 8 units to the left, we still land on the same graph. This is because that this k over here is an integer. So if I were to, let's say, let's place k equals to 1. So g of x minus 8, right? If k is 1. So that means we are basically moving, just g is here, right? We are basically moving 8 units to the right. So there you go, landing on this graph over here. And if I were to put k equals to negative 1, then we will get plus. So that means you're moving to the left by 8. So we'll land on this graph. So we'll find similar family of functions for this tile, and this tile over here. That's what they're asking us to do. Okay, so let's start off by finding this tile over here. So this tile over here. Okay, so this over here is f of x. Now f of x and g of x are quite similar in a way that even if I move, like, it's the same thing. So if I move f of x 8 units to the left, we'll land here. If I move f of x 8 units to the right, we'll land here. Okay, so it doesn't quite matter. So we can say that y equals to f of x minus 8k, or you can even write x plus 8k. It shouldn't matter. So plus or minus doesn't matter at all. Okay, I'm just gonna go with minus, but even if you write plus, shouldn't matter. Okay, so that's for f of x. Now if I were to do this over here, I'm going to do this function in terms of f, because we know the translations to apply to go from f of x to this function over here. So for that, if I want to move f of x to the red graph, we'll go 4 units to the right and 4 units down. So the red graph is basically f of x minus 4 take away 4, right? So that is the translation. So we can say that y is equals to f of x minus 4 minus 8k minus 4, right? Because if we move this graph 8 units to the right, we'll land on the same graph, and if we move 8 units to the left, we'll still land on the same graph. So it's still the 8, okay? 8k is still constant between this. Okay, so now we have the remaining one, which is just this one over here. Okay, so for this I'm going to use g function over here, right? Because if I want g of x to become this, how do I go about that? Well, we have to first move 4 units to the right, and then we have to move 4 units up, right? So this green graph basically is g of x minus 4 plus 4, right? So we can say that y is equals to g of x minus 4 minus 8k plus 4. Now again, you can write plus 8k here as well, and this would be equally correct. It really doesn't matter. Okay? I'm just going to go with minus to keep things consistent. Whether you write plus or minus for the 8k, doesn't matter. Okay? So that's that for this question over here. Let's move to the next page. Oh, question number 5. Okay, nice. So f of x is equals to e to the power of negative ex. Show that the rule and the domain for f inverse is this. Okay, so because it's a show that question, we have to definitely show some working out. We can't just simply substitute stuff in. So we'll say that y equals to f of x equals to e to the power of minus ex, and then we have to say swap xy for inverse. So we'll say x is equals to e to the power of minus ey. So then we'll have log base e of x equals to minus ey, and then y equals to minus 1 on e log base e of x. So our f inverse is going to equal to negative 1 on e times log base e of x. Okay, so that's that. Now of course the domain is going to be this. So domain equals to 0 to infinity. Now that is because the fact that we are dealing with log, and log is only defined for that domain. Okay, so that's that. Okay, so the graph of f and f inverse are shown below. The unique intersection point 1 on e and 1 on e is also labeled. Cool. Find the exact area of the shaded region that is bounded by the graph of f, f inverse, and the coordinate axis. So we are looking at this over here. Let's draw a line. So for this region over here, we can see that that's the area under the f of x graph, right? So our first bit of the integral would be from 0 to 1 on e f of x dx plus, now if we look at this area over here, that is below f inverse, right? So we have to say that from 1 on e to 1 f inverse of x dx, and this together will give us the area that we want. Okay, so let's do this on CAD. So let us first insert a new problem. So insert new problem, and let us define f of x. So define f of x equals to e to the power of e times, oh, why did I write 2? E times negative ex, so negative e times x. I believe that's it. Okay, cool. And we will find the inverse of that. So solve f of y equals to x. Oh, forgot to add the brackets. Comma y. So this is the inverse. Now, we have to find the integral. So menu for 3 from 0 to 1 on e f of x dx plus integral from 1 on e to 1 of this function over here dx. Okay, so that is our area of the shaded region. So let's copy that down. So we have 2 times e minus 3, everything times e to the power of minus 2. Okay? Alright, so let g of x be this, where a can be all real numbers except 0. Consider the function g1 of x equals to e to the power of ax, where a is 1 on e. Find the equation of the tangent line to the graph of y equals to g1 of x at x equals to e. Okay, so let us define. So define g of x equals to e to the power of a times x. Okay, and then for g1 of x we have a equals to 1 on e. Okay, and now we have to find the tangent of this graph at x equals to e. So we can say menu for 9 that comma x equals to e. So x, just y equals to x. Okay, y equals to x. So sketch the graph of g equals to 1 and inverse on the axis provided below. Label 2 equations of asymptotes and the coordinates of the point of intersection between two functions. Okay, So in that case, what I'm going to do is I'm going to define the g1 function. So define g1 of x. So that is the inverse, or not inverse. I'm going to say that that is the, oh actually, yeah, let's just define gx as that. Okay. So then we'll have g inverse. So define. So actually, let's solve for the inverse first. So solve g of y equals to x comma y. Okay, so that is the inverse of g1 of x. So let us define that. So define g inverse of x equals to that. Okay, and now let's find the intersection of this. So solve g of x equals to g1 of x comma x. Okay, so control enter. Okay, so x equals to 2.7182. Wait, that sounds like e. Yeah, it is e. So our intersection is going to occur at e and e. So let's label that point first. So 2.718, so somewhere here. Nah, it's actually too far, like somewhere here maybe. Okay, so that is going to be our intersection. Let's plot the graph of g, so control I2, so g of x. Okay, so g of x is going to be this over here. So our asymptote we can see is y equals to 0. So let's draw that on the graph. So we got y equals to 0, and of course this line has to be a dotted line. So okay, and the shape is pretty obvious as well. So now we just have to check the scaling, because, well, we don't want to scale the graph incorrectly. We already have, this is going to be the y-intercept, and that is going to be our intersection. So I guess we can draw something like that. Let's try again. Actually, no. Okay, well, alright. Okay, I guess this will do. And for this is our g1 of x, so g1 of x. And now for the inverse, I'm going to draw that with blue. Okay, and we have to remember that this is going to be our intersection point, so this has to pass through that. Okay, so what we can do, the other thing is that, well, to draw the inverse, basically x and y coordinate flips. So for inverse, if y equals to 0 is the asymptote for g1 of x, so then the asymptote for g1 inverse of x would be x equals to 0. So let's draw that as well. X equals to 0, and we have to do the dotted line. Okay, I guess this would do, and we can label this as well. And then since the y-intercept of g1 of x is 0 and 1, the x-intercept of g1 of inverse would be 1 and 0. So 1 and 0. And now we have to simply match this. Like that. And we do continue that down. Like that. Okay, so that is our inverse. So g1 inverse of x. Oh, I did say I'm gonna draw this in blue, so I'm gonna, okay, and blue. Okay, so then our intercept is going to be e and e. Okay, so that's that. Okay, Alright, so now let a equals to minus 4 and consider g of 2x is equals to that. Find the rule for g2 inverse. So the inverse, we have to find the inverse of that. Okay, so let's do that real quick. So we have I'm going to define g of x as e to the power of minus 4x. Okay, and now we'll do solve of gy equals to x comma y. So this is our inverse. So that means g2 inverse of x is equals to minus log base ex on 4. Find the values of x where g2 intersects with its inverse, correct to 3 decimal places. Okay, so let us plot the graph for this. Okay, so this is the g of x that we just labeled to be equals to minus 4x. And now if I do the plot for the inverse, which is just this. Okay, so menu for tourism box. Okay, so there are 1, 2, and 3 intersections. So it's good to always check graphically for these questions, because in some questions you have the graph like this. If I draw y equals to x, y equals to x. So let's say that you have your graph like this, right? So that will be like that. This is your f of x, and this is your f inverse of x, for example. Okay, so as you can see that both of the intersections occur at y equals to x. So in some cases we can also say, to find inverse, we can say that f of x is equals to x, or f inverse of x is equals to x. That is also perfectly fine, but please make sure that you graphically check this, because if I were to draw y equals to x, well, there's only one intersect here, right? But in reality there are 3 of them, so make sure that you guys always check before you use this. Very important. Okay, like the safest way out of these questions is just saying f of x equals to f inverse of x and then solving for x that way. But sometimes the CAS cannot do this because the equations are a bit too heavy, so that's when this come into play. Okay, hopefully this made sense. So let me erase everything up. So for this case, if I come back to the CAS, so for this case I'm just going to say that g2 of x is equals to g inverse of x to find the x coordinates. Okay, and see if we can find it that way. If not, we have to figure out some other way, but let's try this way first. Comma x. Okay, there we go. So we can. So let's write it down. So x is equals to 0.00, what is it? 3 decimal places. 0.028. X is equals to 0.301, and x is equals to 0.894. Okay. The value of a determines the number of intersection points of the graphs g and g inverse. Complete the following table by stating the values of a in each case. Okay, so we will find the values of a such that there are 0 intersection, there is 1 intersection, there is 2 intersections, and there is 3 intersections. Okay, we are given that when a is between 0 and 1 on E, we have 2 intersections. And we will find such bounds of a for other cases as well. So what I'm now going to do is I'm going to find the g of x. I'm going to define g of x in terms of a, and then I'm going to find the inverse in terms of a and then play around in the graph window. So let's define our function. So define g of x is equals to e to the power of, I think it was a times x. Let me just quickly check. Yes, okay. So now if I were to solve for inverse, menu 3.1, g of y equals to x comma y. So this is the inverse of g in terms of a. So I'm going to define, so define g1 of x, which is the inverse, is equals to this. Okay? So now we have the g and g inverse. So now let us plot this. So I'm going to erase this graph to g of x. Okay. And I have to plot another one. If it lets me, okay. Control, so graph entry edit, another function, g1 of x. There we go. So this is when a equals to 1. Okay, so as we increase from a equals to 1, graph does not intersect at all. So that's one good thing. So a can't be 0, that is a part of the domain. So if I do negative, okay, there is one intersection here, clearly visible. There is one intersection here as well. Okay, now there may be more than one, or maybe the graph is just tangent. Let's see. Yeah, no, there's 1, there's 2, there's 3. So there's 3 intersections for equals to -3. Okay. What I need to do is maybe let's check the bounds for 2 intersections. So from 0 to 1 on E. So if I do, what is 1 on E? 1 on E. 0.36. Okay, let's try 0.2. So 0.2. Okay, and if I do zoom out, menu for 4. Okay, there we go. So this is when 2 intersections occur. Oh yeah, and this is what I wanted to tell you guys as well by saying, so if I draw another graph, function x. So as you can see that both of the intersections occur on y equals to x, right? So this is what I was saying before. So I guess for some values of a, this is true. So make sure you guys are, aware of this technique as well. Okay, I'm going to remove this graph for now because I don't think we need it. So this is 0.2, and if I do anything greater, okay, maybe I have to adjust the step size. So settings, step size, I'll say maybe 0.1. It's a pretty low step size. So, but anyway, so if I do 0.3, we still have that. Yeah, so 2.4, so 2.3, we should have 2 intercept, and from 0.4, we should have none. There. So 0.4, we have none. Okay, so 0.4 onwards, we have none. So basically, if a is greater than 1 on E, we have no intersection. So let's write that down. So for 0 intersection, we have a is greater than 1 on E. Okay? I'm curious to see what happens at 1 on E itself, because 1 on... Oh, okay, so the graph has exactly 1 intersection point, if I'm not wrong. So if I do menu for 2, if I do that, yeah, I think there's only 1 intersection. So menu 6, 4. Yeah, there you go. So it is only 1 intersection, and it's intersecting at E and E, I'm pretty sure. Right, so at A equals to 1 on E, we have 1 intersection. So let me zoom out a bit. Okay, so I guess we can write that down as well, that A equals to 1 on E. We have 1 intersection. Okay, now let's try and find for 3 intersections. So, okay, that is still 1 intersection. Also, A equals to 1 on E is not the only solution. Now when does the graph has 3x intercept? So let's see, 2.43. Actually, what happens if I do solve g of x equals to g1 of x? Because the a value is already defined as negative 2.43 or whatever that was. Oh, solving for x. So there's only 1 intersect at this. So if I were to decrease the value further down to 3.23, now what happens? Okay, now there are 3. Let's make it bigger again. So 2.73, let's see. 3. Let me zoom into this. Oh, it is literally just like it has 3 intercept, but it's just touching. Oh, 2.73. That seems close to E. Let me 2.63. What happens at 2.63? 1. Okay, maybe it is at E when things start to change. So at E, 2.72. Let's see this. 1. So now if I were to decrease the value even by a slight bit, actually let's say 2.73. We should get 3 intersect again. So there we go. Okay. So if A is less than negative E, we will have 3 intersections for the graph. So let's write that down. So A is less than negative E. Okay, so that's that for 3 intersections. Now we still have to figure out for 1 intersection, because we did see that if it's greater than E, there is still going to be 1 intersect, right? So let me zoom out, maybe 4. Yeah, there's only ever going to be 1 intersection. So, okay, so then from till when will it only have 1 intersection? So 4, zoom out a bit more. So it's negative 0.43, still 1. Okay, now it will intersect twice because, wait, let me see, will it? 4. Yeah, it definitely would intersect. There you go. So it does intersect twice. Okay, so now if I do 0. So negative, if it's still in negatives, it's intersecting once. What happens? Positive. Yeah, so that intersecting once and intersecting twice. So I think it's at 0. What happens at 0? It's just a flat line. Oh, but A can't be 0. So if I do negative 0.02, still 1 intersection. I think it's from negative E to 0 when 1 intersection occurs. Because at 0, the graph is not defined because A can't be 0, so that's out of bound. But as soon as I increase it to positive, let's do positive. Yeah, now if there is going to be an intersection, like 2 intersections, so menu 4. Oh. There you go, so there's 2 intersections now. So as soon as the graph is great, as soon as the A value is greater than 0, there is going to be 2 intersections. Apart from when A equals to 1 on E, because that's when we noticed that there's only 1 intersection. So if I do 1 on E, yeah, so now if I do menu 4.2 and then zoom into right. No. Oh my god. Okay, maybe if I move this, oh damn. Okay, maybe I just have to zoom in like that. Okay, fair enough. And what was the value? It was 1 on E, right? Okay, 1 on... There we go. So as you can see, it only has 1 intersection at 1 on E as well. So I think the bounds for having only 1 intersection is going to be when A is between negative E to 0, including when A is 1 on E. We can't have 0 included because A is not, that's out of the domain for A. So we can't have that. At A equals to negative 3, we did notice only 1 intercept. But as soon as the A is less than negative E, we have 3 intercept, which is here. And yeah, I guess that's it. Yeah, I think that's it for this question. I mean, there is a way that we can check. So if I were to draw a number line real quickly, so let's start by what they have given to us. So from 0 to 1 on E. So from 0 all the way to 1 on E. Okay, so 0, 1 on E. We have to intersect. Let's go from here now. So A is greater than 1 on E. So that is our second domain. So A is greater than 1 on E. Okay, that is for 1 intersect. 0 intersections. Then we have negative E to 0 and 1 on E. So now this 1 on E is included. Okay, and negative E all the way to 0, like so. Okay, and then from A is less than negative E, so less than negative E, we have 3 intersections. less than negative e. So I'm going to say that this is over negative e. There you go. So everything is basically covered in the number line. So that does make sense. So what I mean is, whenever we have these sort of questions, is normally like, the entire number line should be filled up. Like if you see here, all of the values are defined. The only thing that is not defined for a is basically a equals to 0, which matches what we have here. So that is fine. We don't have to worry about that. So I guess one way to check is the fact that as long as everything on the number line is defined for a from negative infinity to positive infinity, then your answers are most likely going to be correct. But make sure that, if there's any exceptions for the variables, like, a can't be 0 in this case, make sure you address that as well. But apart from that, I guess this is one way to check. And so far, I think the answer seems to be correct. So I'm just going to leave it as that. Okay, next question. Oh, end of the... Okay, cool. So I guess this is the end of the NHT Section B for Methods Exam 2. Thank you for watching. Hopefully you learned from this. And I'll soon see you in my next video. Bye-bye.